Yo, 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 what's up, everybody? Welcome back. Today we are working on our Wayland window manager, compositor, whatever you want to call it. And we're on day 2 of this thing. We don't really have many hard goals right now, but we're kind of working on this thing because I'm working towards writing an operating system for my phone. And one of the things that you have to do on your phone is you have to like look at the screen and see stuff on it, right? And so if we want to do that, this is kind of like a good thing to have in our back pocket, a Wayland window manager that we've written so that we can understand the differences when we get to the Android side of what is the difference between, like, what is this supposed to look like? And then we can kind of like adapt that so that it matches whatever those like Android drivers want, right? We are also maybe going to use this as our real window manager for real, but you know, who knows? We got to the point yesterday where we could, you know, run a window manager, and if we try to connect our client to it, we have a bunch of, you know, chatter between the two boys. And we get to the point where the client is trying to render. And we don't like support that yet. And so that's today's goal, is to try to do any form of like client rendering in our Wayland server. So just for a little bit of context, we're going to rip through it quick because we've kind of explained this yesterday. We have window manager over here. He exposes himself on Unix socket, right? We have client over here. Client will, you know, initialize some like GPU buffers, maybe some like CPU buffers, something. He's going to have some sort of like chunk of memory that is either GPU or CPU owned. And he's going to export this thing as a DRI prime file descriptor. So one of the messages that he can send over this like Unix socket with a defined, you know, Wayland protocol is he can like export this thing to a file descriptor and ship that file descriptor over here with a bunch of like extra metadata, and then this guy can like import that file descriptor and display it. We have in the past this example of us in a virtual machine, you know, displaying something to the screen. So we have like a way to render to the screen, and so we just kind of like have to like hook these two halves together, where we have like a guy who can talk to a Wayland client and a thing that can draw to the screen. And so I guess like we talk to the Wayland client and we draw it to the screen. Sure. So plan of action is to, you know, try to get those GPU buffers over the Unix socket, import them, you know, so that we can like interact with them in some way, not just like in file descriptor mode. Then we have to like hook up this little test app to our Wayland thing, our Wayland window manager. Once we can like have display working over there, then we can like display the client stuff, and then we'll figure it out from there. That's the plan. That is the plan. Let's get moving. Okay. So, what is the message here? Wrong main. Wrong main. We want to be in this one. So somewhere in this like long list of messages, the thing that is interesting is this WL surface commit. This is Wayland surface. So we kind of render, there's kind of like windows and surfaces. We have like a surface in a window, and we are trying to render that surface. So this surface is kind of like an abstract concept in Wayland. Though they actually are trying to render is the XDG surface. So it's kind of like, I think, wait, hold on. I have to draw it out. I'm missing a piece. So there's like WL surface that is kind of like the generic version. There's XDG surface, which is kind of like, hey, I'm like a desktop shell and I want to make one of these or connect to one of these. And then there's also like something like ZWP buffer. And I think this also points to this. Let's see. Let's look at the client code and try to figure that out. Windowsig, probably. So when he calls swap buffers, he creates a ZWP Linux buffer parameters, which is attached to a Wayland buffer. The Wayland buffer gets written to the surface. Okay, so we're missing a piece. So we have, it's kind of more like this. More like this. WL buffer is like here, and that our Linux buffer goes here. So this has all of the like interesting info. And this is just like connection data, basically. This is just for like tracking purposes, I think. I don't really know, but we'll see. So I guess that means that we have to track these boys. That's kind of the answer. We let's just start by trying to do any tracking of this. So we have surfaces. I think we also need WL buffers here. And I don't know what is going to be in here yet. But presumably he is going to have, hold on. I need to look at the protocol. We need to look at the protocol. I guess we can look at also our client usage of this thing again. So he creates first buffer parameters. Then he creates a WL buffer, which he attaches to those parameters. And then, is that it? I guess there is no like ZWP buffer. So it's actually more like this, the ZWP buffer constructs this. Constructs. That's a word. So I guess from our perspective, we do need to support the ZWP thing, but we don't have to store anything for it. We only have to store the WL buffer. And after we are finished with it, I think we're supposed to release it in some way, if I remember correctly. Yeah, there's WL buffer release. So we are going to render this thing on like the next iteration of our render loop, and then we're going to release him. And so we have to write down all of the stuff that we want for rendering. So that's what's going to live in here. So he's going to have things like, you know, maybe we process this stuff like off rip. So maybe this guy gets like, you know, whatever format DRM wants us to store in. So I guess for now, I'm just going to throw like a thing in here so that, you know, so that it's not empty because it's going to fall over if we don't do that. And let's just try to figure that out. Okay, so when they call ZWP Linux buffer params, this is where they are trying to create something, I think. So he starts here with DMA buff create params. So since these parameters are like kind of temporary, we do need to write these down. So we have like kind of like in progress buffer construction, which is interesting. So I guess we have this guy too, ZWP params. Buffer params or something. I don't know yet. And in here we have a bunch of stuff that isn't initialized yet. Right? So they're going to eventually call this stuff on here FD. So we're going to have like, I guess it's kind of more like this thing holds optional params. Because I guess, yeah. So at some point this will get set, but initially he's empty. And so this guy's going to have all of this stuff. That was a bad copy paste, huh? Offset, stride, modifier. Something like this. Something like this. He's gonna get all this shit. Hello? Oh, it's a tab, that's why. Okay, there we go. There we go. Oh my god, this is... I should not have copy-pasted. This is not worth it. Okay. So, this guy has, like, ZWP params initialized here. And when he gets this, like, create params, we go... like this. We go, ZWP params, insert, with params ID, and we are inserting a null entry here. This has not been set yet. He doesn't like this. Why? Expect 3 arguments, so we need allocator here as well. And then when he tries to like add things, we say, wait, what does he like here? Oh, we need to parsed, switch on parsed. So when he calls add, we go, state ZWP params get pointer given this ID that we're looking at. This is the buff params here, or else return error invalid buff params. Boom, easy. This is object ID now. Zig has some weird ass syntax, man. Structs are const variables. I don't like it. Yeah, they're just like types or values. Kind of sick. I think that like getting hung up on syntax, like it doesn't really matter. It doesn't really matter, man. Buff params is equal to some shit. So what is in here? What is in here? All this stuff. Boom. Okay. FD is equal to undefined. We need to deal with this in a minute, but file descriptors are sent out of band, which is a little annoying. But the rest of this stuff should be in here. Plain index is equal to params. It should just be like this. Offset, stride, and then modifier came in 2 halves. So it's like const modifier U64 is modifier low, and then we say I guess it's high comes in first, and then we do modifier shift left by 32, and then modifier or equals params modifier low. There we go. Okay. So then they're gonna call create on this thing. Let's do like unreachable here, and just write FD needs to be fetched, but we'll get there later. If they call create immediate, we like upgrade this thing from a buffer params to a buffer. So I think that we say here like state WL buffers, we like insert a new thing in here. I don't know what yet. Object ID elem. So this is actually, hold on. Buffer ID, I think, goes in here. Yeah, so this is the new buffer ID. And we are trying to insert something that I guess at least has the params, like buff params. So we're gonna like say like buff params is state ZWP params get from object ID. You know, then we like set these in here. Boom. And or else return error invalid. This should be like invalid object, I guess, is a better name for when this fails like this. So he like hucks that shit in here with the rest of the shit, right? So he also has these WL buffers. They have params, come from buffer params. And then they also have this extra shit. Width, height, format, flags. Format, flags, right? Easy. So then we're like this. Width is params width. You know, height. Format, flags. All right, cool. Oops. Like this. We call it buff params. Okay. Oh, so this is a double null, right? So if this is like buff params opt. Buff params is buff params opt or else return error empty ZW params. There we go. Cool. So this guy's not happy for some reason. Because these are I32s. For some fucking reason. I don't know how your width and height could be negative, but yeah, I guess fuck me. Okay. So now we like have these things sitting around. And we have to like turn them into GPU buffers. So the thing we're missing though is this file descriptor comes in, and this file descriptor comes in out of band. Right? So like the way it works is there's kind of like Unix dgram, datagram. And like in here, you're gonna have like your typical like data, right? That you fetch this with like a read call or something, like a read sys call, right? But there's also sometimes like what they call ancillary data. And this stuff is like parsed with very specific like C APIs, C message, if I remember correctly. And in here is our file descriptor. And what's also interesting is that like, you know, usually when you have like a long string of text, right, you'll like chunk this up into like packets and send those packets over the wire, right? And then like when we read this back, we like reconstruct this and like parse it as we want to, right? So maybe like your header is here and the data for that, you know, message goes across a packet boundary, and then you read like your next header packet, right? But then like where does the ancillary data go in here? If one of these like Wayland messages, like logical Wayland messages that spans packet borders, if it has a file descriptor associated with it, like the file descriptor is associated with one of these Unix datagrams. So like where does it live? And I was looking this up before stream today. If you look at like Wayland protocol wire format, I think is actually what the term is. Here they talk about the protocol does not specify the exact position of the ancillary data in the stream, except that the order of file descriptors is the same as the order of messages and the FD messages arguments within messages on the wire. So I think that this says, yeah, in particular, it means that any byte of the stream, even the message header, may carry the ancillary data with file descriptors. So I think there's like not even a guarantee that the message that, like any of the packets that hold a message for this data have the file descriptor attached to them. I think that's not even guaranteed. I think what you were supposed to do is like have a stream of file descriptors that we got and like pop them off this stack, right, as we get to them in our parsing, I think, which is like kind of fucked. But like fine. So I think the way I want to structure this is we need to use like a special syscall to get these file descriptors, right? We have to use I think it's read message. Man read message. Hello? Man read message. The fuck? Oh, receive message. I've just never seen this log before, so I was like confused, but I think it doesn't matter. So receive message. Which says you pass in a message header, and this message header will like have a spot for you to put ancillary data, if I remember correctly. We have to send this data. So if we look at C message C, we literally only have sending. Yeah. Okay, cool. So what we have to do is, I think, we want to write like a Zig IO reader. Zig IO reader. And, you know, his like typical path just reads data as normal, right? However, it cannot use read, right? He has to use receive message because any single packet that he reads might have a fucking file descriptor associated with them, right? And so what we have to do is like check for, like as we read, check for file descriptors and basically like put them out of bounds somewhere, right? I think. So like what I would think is that we have like, reader, and he holds like the socket file descriptor, whatever, and interface as like your, this is how you're supposed to do Zig IO readers, I think. Stood IO reader, right? Oops, stood. Right? Then on like the interface to IO reader, I think we provide a stream function that takes, that tries to like this stream function. I don't know, like this guy needs to call receive message, pass data to where, Zig wants it to go. But then also here, we're gonna have like a like FD list, which is gonna be some sort of like expandable, like circular buffer, probably ring buffer. And so what'll happen is we will like kind of like send this stuff through the Zig IO system as normal. But then here, when we actually need a file descriptor, I think here we call like reader FD list pop or something, right? And I think this is how we get our file descriptors out. And then everything else should just be able to kind of like work as it was before, like very simply with Zig's IO system. That's kind of like the idea I have. We'll see if it works. So I guess we can kind of just start ripping this shit and see what happens. We have a circular buffer implementation that's like pretty designed for this. No, it's not. It doesn't expand. It doesn't expand, but that's okay, maybe. Maybe for now that's okay. Let's pull in our standard library. I think it's time. Stud. And I guess that means that here we need to like get submodule add stud comes from like get stud. Like this. And then I think we want to like update our Git modules. I think we want this to point adjacent actually. And then we, in our build zigzon, we say, hey, we have some dependencies. Stud. And this is just like from a path of stud. Boom. Then somewhere in here, we are gonna have like somewhere that's like import stud. And he's gonna be like, I'm gonna give you a module. And this is gonna come from dependency of stud, module stud. Easy. I think this is mad that he wants arguments here. And then when we make our server, he wants stud as an input. We go over here and we say, yep, he can import that thing. That's fine by me. And then we just need to, when we call this, pass in stud here. And this is builder import stud. Boom. Should be all fine. Yeah, so ring buffer is wrong now. This is stud util circular buffer of stud POSIX FDTs. Okay. Cool. So now we just have to figure out how the fuck we're supposed to work with this thing. I don't know if I've made one of these IO readers before. So there's discard, read vec, rebase. Read vec by default just calls into like your stream implementation. Rebase also, like what does default rebase do? He just moves data back in the buffer, sure. So if we had like data that, a backing storage that worked a little differently, we could do something different. We don't need to do that. Discard, I assume, just calls stream into discarding writer. Great. So I think maybe we should implement readvec, but probably not. I think we're good enough to just implement stream. Does the doc state that FDs come before whatever data? That pop will always exceed, or will they come in the same order? Yeah, I guess you're right. That pop might not work. Which means that we need to like delay eating the message until the data exists. Yeah, you are right that there's something there that I didn't consider. Except that the order of file script is the same. Yeah, you are right? It's that pop idea. Yeah, maybe that doesn't work. Good eye. So here, how would we want to handle that? Can we maybe do something like this, where maybe we handle the file descriptors separately? What would be nice is if we could just delay parsing this message until the file descriptor's there. You know what I mean? So it would be kind of nice if we could do, like, maybe at the top level here, like, if this could be, like, you know, if request requires FD, right? We can do like this, right? Reader pop FD or whatever. And then that means that this parsing stuff needs to not consume data, right? So this needs to be like, yeah, let me think. This needs to be like, or else wait for FD, right? Something like that. However, I think we can probably assume it's there. Because, like, in what world would someone send this stuff and not attach the file descriptor to anything? Right? Surely it's attached. I think you're right that that's like, it's probably not quite in spec. But I think as long as we consume as much data as we can when we read from the socket, like, surely we'd be okay. I guess, like, you could see a world where someone's like serialized messages and then, like, attach, like, send FDs we haven't sent yet. Like, I guess you could see a world where somebody does actually do that. That's not like a crazy implementation, and I guess it'd be kind of nice to support that. Sure. Okay. I at least like this. And then maybe at least for now, let's just maybe do this. Right? We can, like, at least crash here. But I do like the idea of, like, forcing us to check that it, like, this feels nice at least. This is, like, easy to implement. So let's at least do that. You know? Okay, cool. So this guy gets, like, an optional FD here. So I think it's like FD is an optional C int. I guess, like, stood POSIX FDT here. We'll come back to this. Ample. Here, he passes in the file descriptor here. This guy gets an optional stood POSIX FDT here. And then that makes it easy for when we get this thing. It's just like, this is FD, bitch. Or else return error. I guess this is, like, unreachable. Right? Because, like, the code should say, like, our bindings should always say that this thing requires an FD, right? Always. Okay. So... sure. Okay, so now we just have to implement our reader. Easy. So... Can we try to construct this thing? So let's start by, like, who owns the reader? Like, the main loop somewhere, right? When we create, like, our IO reader here, this has to go through our thing, right? So we need to be like, var stream reader is connection stream. This is like our Wayland reader, right? Let's call it WL reader maybe. And we're gonna have like stream equals connection stream. Okay. Interface is stud.io reader whose vtable is stream is WL reader stream. Like this. Okay. Here we need this guy to be defined as WL reader. Okay. Something like this. Oh. Let's just call this inner or socket. Maybe is a better word. Pairing up as streams eventually advance to the same point seems like quite a burden on the server, especially since making progress on the ancillary stream requires one to consume the data stream. I wonder why they didn't tighten that up. Yeah, I agree. Doesn't seem great, but whatever. I think that we can like kind of rely also on some form of like reasonable behavior, right? As long as our buffer is big enough, right? Maybe 4K is like a little small for that, but like surely if we give them like a meg, like we're never gonna run out of room, right? A meg is too much, but like you know what I mean? Like there's some amount that you could like pick that would be reasonable. There's a typo on line 12. Maybe. It seems fine for now. We'll figure it out. Typos are easy to figure out too. Okay, so this is now stream reader interface. This guy clearly, he needs a buffer, right? So he's got like seek is 0, end is 0, and his buffer is reader buff. Boom. Okay. Cool. No interface in struct WL reader. That's probably what you're talking about, huh? Interace. Okay. So this guy wants this function signature. Yoinkies. All right. Boom, self. I guess we call this reader, writer, limit. Okay. And now we just got to figure out what the fuck we're supposed to do about this, right? So here we figure out where our WL reader is based off of this guy. So we kind of say like field parent pointer. So we're looking at R and we're looking, he is the field interface in my parent, right? So we kind of like do this. Now we have access to socket and we can call, do we have like receive message in here? No. OS Linux receive message. We do have this guy. Cool. So I think there's also like receive many messages also, which maybe is better. But like whatever. This is probably good enough for now. Because I think that the way that it works is that each receive message is explicitly one datagram, if I remember correctly. Because like the way that the Unix sockets work is that like you can kind of assume that each packet is like, you don't have to worry about, you know, packetization and network and stuff because it is like in the same computer. So they can't just like take the thing you sent and like put it over there. So it could be that we're like kind of wasting, like it could be that we're like reducing the effect of buffered reading by only reading one at a time, right? So we might want to read many. but this is going to be fine for now. So we're looking at our self socket handle. This is the file descriptor. And then we need to figure out what goes in this message header thing. Man, receive message. So he takes in the socket. Message points to a message header structure containing both the buffer to store the source address and the buffers for the incoming message. The length and format of the address depend on the address family of the socket. Sure. Can we just not do that part? Like, if we just like huck a null in there, is he going to be upset or is he going to be fine? Message header. Message name may be a null pointer if the source address is not required. Otherwise, if the socket is unconnected, message name member points to the socket address structure in which the source address to be stored. Blah blah blah. Name len could be 0 probably. If the socket is connected, blah 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 blah. The message IOV and IOV len fields are used to specify where the received data should be stored. Great. Message IOV member points to an array of IOVEX structures. So what I'm not clear on right now is like, can we store this directly into our reader buffer? Like, so like, oopsies. Like the IO reader has a buffer in the interface, right? So do we put it here? But then what is this writer for? Yeah, what is this? Like, what is this interface? Is it like, can we just look at like reader stream? Okay, writes bytes from the internally tracked logical position to W. Returns the number of bytes written, which will be at minimum 0, and at most limit. The number returned, including 0, does not indicate end of stream. Reader's internal logical seek position moves forward in accordance with the number of bytes returned from this function. Implementations are encouraged to utilize mandatory minimum buffer sizes combined with short reads in order to minimize complexity. Although this function is usually called when buffer is empty, it is also called when it needs to be filled more due to the API user requesting more. In addition to, or instead of writing to W, the implementation may choose to store the data in buffer, modifying seek and end accordingly. I see. Maybe. Okay, so when we call, aren't we the writer? Like, are we calling this with ourselves? Like, who calls this? So if I go into like IO reader, and in here somewhere, like, can we just call like how does the function of just like read alloc work, right? He calls read slice all on some length of stuff, right? He's like, I want to read this many bytes. So he like allocates that thing. He says read into that slice, which calls read slice short. In here, he tries to copy from his like internal buffer, right? Reader buffer. And if he's like out of shit, then he calls read vec into this. Okay? So he creates a vectored read of size 1, which contains the output segment. Okay. But doesn't that mean that like we're not like our buffer never gets filled up if we just do this over and over again? Because he's only reading directly into the buffer? Unless read slice, yeah, that's confusing. I guess maybe this just doesn't take advantage of the internal buffer then. Okay, but then like what about like if we call like fill? Here we're like, fucking rip that shit as much as you can. Go to sleep, later. So here, Like, am I fucking high? Oh, you know what? This is clever. Oh, wait, that is fucking sick. So I think read vec, is he going to like append his own buffer as part of the call here? Because like here, where we just were in like fill maybe, he's passing in to read vectored a buffer that is fucking empty. He's like fucking read vec, but there's nothing here. So that means that like internally they must be appending their buffer to the like the list, right? So they have first. R bufferlen. Yeah, there's something interesting here. So they are calling the writer with their own buffer. Then where does data come into play here? Leo, thank you for the 5 gifties. Much appreciated. He's only used... What the fuck? Writes to reader buffer or data, whichever has larger capacity? Oh, why? Isn't that fucking crazy? Because, like, here, that means that this read vec might not write into data. Which means that, like, whoever's calling, like, read slice short, fill buffer with the next buffer len bytes on the stream, advance the Zeke position. So, like, if we get to here, and this is undefined. While true, they try to read into this data buffer. Dude, how confusing. How confusing. So this read vec is going to R buffer from seek to R end. Oh, so first they check if they have the data buffered. Then they will copy into data if it's already there. For data buff I. What if this is too long? Like, won't this freak out if seek to R end is not big enough? I guess if seek to R end is too small, this could be like a buffer length of 0, then copy length would be 0, so then they have 0 copy length here, got it, then they advance this thing. Then all of buffer has been consumed, and then they're calling read vec directly. Data I is buff. Whoa. Read vec is outputting new slices? Oh, I just didn't understand this interface at all then. Oh, I think I understand now what's happening. So, hold on, my brain. When I call read slice short, they construct a one-sized output of slices here. But this could be like 10 of these things. If we were allowed to read in 10 chunks or something, right? Then in here, they first try to use hold on. No, I'm lost again. So do they ever use this buff directly? This buff is data. Dude, what the fuck? Is this not like modifying itself? Data I is buffer. No? So they're taking like data I and they're saying, oh, I'm gonna like temporarily reassign this and then put it back later. And then they're doing it. Oh, that's clever. Oh, I see what's happening. Oh, that's kind of nifty. Okay, so they're saying like, they're doing something like this. It's like you come in with, you know, like sets of buffers like this, right? Then they consume as much of this as they can from the buffered data, and then you're like here, and so they're like, okay, we'll call the like real read vector to vectored read into this and this, and then but then when we're done, we have to put this pointer back. We have to like undo what the fuck we did. That's clever. That's clever. Too clever, but okay. So then they call. Anyone know the background sound name? I cry flow right out. I didn't. I don't know how this ended up getting here. Okay, so then when they say the vtable read vec, this is confusing to me because it can choose to read into whichever is bigger or something. It said data may not contain an alias to reader buffer. Data is mutable because the implementation may temporarily modify the fields in order to handle partial reads. Implementations must restore the original. Implementations may ignore data writing directly to reader buffer, modifying seek and end accordingly, and returning 0 from this function. Oh. So if I decide I would rather read to my own buffer, then I return 0 from this thing. And how does that help here? Because this will return what he got. I see. So then read slice short. He will be like, won't he get returns? Oh. So this thing will say I plus equals 0, and he'll go through another iteration of this loop, call into read vector it again, which will copy from the buffer. Okay. Okay, so I think I understand that. What question were we originally trying to answer? It was, what the fuck am I supposed to do with stream? So the default implementation of read vec he calls into stream using the buffer is our reader buffer, right? So we can read directly into the writer buffer, and that's okay. And probably, now that I understand, we can probably choose to read into our internal buffer and return 0 if we want. The implementation may choose to store data in its own buffer, modifying seek and end accordingly. Oh no, this is in the output buffer. Reader's internal logical seek position moves forward in accordance with this. Returns the number of bytes written. So I think that we don't write to ourselves. So we don't touch our own reader buffer ever. It's just that when we are reading to ourselves, which we do sometimes, the writer is ourselves. But there might be a case where it's not, in which case I guess that makes sense. Okay, so I think all of that is to say that in this like new API, we're supposed to read into the writer. So we're supposed to call like message header is message header. Our name is null. Name len is 0. Our IO vector is going to be directly into the writer buff. I think, right? So I think our IO vector needs to have one possible buffer that we're writing into, I think. And then I think it's actually better to use like, I guess this is like a Linux specific call. So this is iovec, which is from stud POSIX iovec. So base comes from writer buffer pointer. Len is writer buffer len. This goes here. Right? And then afterwards, we need to do something, right? So receive message. How does he like export how much he read? I think it's in the return, right? Upon successful completion, he returns the length of the message in bytes. Cool. So, right, so this is just like writer. We're supposed to modify seek and len? What is in this thing? Just end. Yes, we just bump end by how much we read, right? So I guess we say like var read here. We need to check if it failed. Receive message. What does it take? Message header. And I think this needs to be variable. And then flags. Out of band data. Request out of band data. So do we want that? Maybe. Peak. This is not peak. Wait all. On stock stream, this request that the function will walk until the full amount of data can be returned. I think we don't care about that either. So we might want out of band data. Because that's, we're trying to get file descriptors, which seem out of band. Can we look at like ancillary file descriptor C message? I guess there's an example somewhere in here actually. It's in like a man2 C message maybe? Right, so here they don't talk about they don't talk about like the receive message stuff here. Maybe like Unix sockets? Unix domain sockets do not support transmission of out-of-band data for send and receive. Okay, but what about I guess ancillary and out of band are different? I guess? I think that our flags are 0. I think. We can also check what we do on the client. Windows. It's like send message with attachment. So make FD transfer message. So he calls send message with 0, right? So we should be able to also receive with 0. Okay. Let's see what it's about. White space on one side and oh, my bad. Okay. So here we want to do like, there's some way that they do this like conversion to Erno. Obtains Erno from the return value of the function call. For some systems, this will obtain, but I guess this is if we're linking against libc, it's gonna call like actual Erno, which is like a fucking problem. So I think we just want to do this. Yeah. Yeah. I guess we would just want like it's less than 0, right? We can just do this ourselves. Man to receive message. -1 if an error occurred. Oh, but this is the fucking C function, right? What does the fucking OS do? What does the fucking syscall do though? Because that's what this thing is doing, right? He's just calling like syscall 3 or whatever, right? So we need to look at like the syscall API. No, I don't want the fucking C API. I want the kernel. I want the kernel. Oh my god. References here. So like, what are these? Yeah, okay. So this is again not helpful because we don't know any X returns. But we can look at the definitions over here somewhere. Okay. So it looks like negative values are errors and positive values are, like, I assume here that it's like S size T error, right? So we say like copy message header from, oh, we return 0 on success. 0 on success. Error, negative error number on error, right? That's what it looks like. That's what it looks like. Okay. So switch if ret is less than 0. Switch on negative signed. And then here we're looking for like stud OS Linux like success. Where does this come from? What do they usually do here? Stud OS Linux like E here. Yeah. Okay. Linux is a stud OS Linux E enum from int signed. And then I guess here we have to be careful that we're not going like out of bounds here, but this is a no, this is like a, he can handle anything that is So, oh, this is the fucking wrong platform. 64. Here probably is. We're probably in this case. But yeah, it's fine. Oh. Wait. This is better. Let's just call this init from syscall, dude. Wait, let's just do that. That's great. Oh, init. Sorry, it's just init. Okay. Yeah, we just do this. Right? Maybe. So on success, it's like writer end plus equals read, right? However much data we read. Otherwise, it is read failed. All right. And then we eventually have to get the ancillary data in here, but let's fucking chill for a second. How do we use limit? Returns the number of bytes written, which will be at minimum 0 and at most limit. The number of bytes returned, including 0, does not do this. Okay, so does that mean that we, like, as an implementer of this thing, need to clamp the writer buffer limit? Can we look at, like, the fucking net stream implementation of this? Like, surely we can use this as a reference, right? Like here, right? So they init interface here, they call reader stream. So they call writable slice greedy with limit. Where writable slice greedy is minimum length. Okay, so they do this, right? And then they read this into dest, just doing like normal shit. Okay. We can do that. I guess. Sure. And then I assume if we were to look at their implementation again, oopsies, stream. Like I assume they just call W advance. W advance, baby. Which is just plus equal, yeah, sure. We would have fucked that up already. I think that we did the wrong thing here. Because we just did writer end. Oh no, that's the same. Ish. Okay. Alright, we're getting close. Field parent pointer. He wants, oh, it's the other way. This thing is, I've got some squigglies. Message header, we're missing control, right? So this is the interesting piece. But for now, let's just do this and see if we get the same shit, right? Does our app still fucking work? Because we need to start somewhere. What is in flags in the message header? Oh, ignored an input, sure. May have meaningful data output, sure. Then here we need to return how much we read. I guess here what we should do is we'll move the success case out here. Let me do this. Okay. We haven't gotten to the file descriptor list yet, but we're kind of hoping that this thing just kind of still works. Which, yes, right? We did read a bunch of messages correctly. We just got to the file descriptor shit and we tried to dereference it and it didn't exist anymore yet. Okay. So, file descriptor list. Here's where we get crazy. How does this control stuff work? How does this control stuff work? So, like, presumably, there's something about, like, CMessage? Man, CMessage, right? So, how do, like, file descriptors get in here? How do these? So these are like, I have this much data length for this thing. A file transfer has 4 bytes for a file descriptor int32. Then we talk about like his level and his type, and we just put that shit in there. So I guess that means that we need like this. This is going to look very similar, right? We're going to have get CMessage space, where CMessage space says like, let me allocate however much like extra shit you need for this thing. And I would love for this not to be a like C API boundary. It would be nice if we could just have this directly, which I think is like probably doable. You know what we could do here? Is we could like zig code gen something that matches the shape of this thing, right? Because like all this is doing is it's saying given this buffer, which is where the C message is going, let me like assign these things, right? But what we could do is we could just figure out what these offsets are and like do this in zig code, right? Because all we really need is the offset of CMessage len, CMessage level, CMessage type. Because everything else here is just nulled out, I think. And then we don't have to hit this fucking boundary. Sure. Can we try that? So we can do like, gen zig CMessage.c or something. So what was that fucking file? CMessage C. Okay. So here we're trying to do something that's like printf something. I don't know yet. But surely we're gonna be like CMessage space 4, right? Because we're looking for like socket size. I guess it's like hold on. FD size is size of int, probably. Right? This goes here. What else do we fucking want here? We're gonna want CMessage len. CMessage level. Or I guess this is a sol socket. So I guess we actually are looking for offsets of these guys more like, right? So we have a struct CMessage header CMessage. And does C have like offset of? I feel like it does, right? Type member, right? So if we're just like offset of struct CMessage header, and we're just like CMessage len, CMessage level, CMessage type. That gives us a lot of info. And I guess we probably also want like the sizes of these things. But CMessage header is just defined in CMessage. So we already So all of these things we already have. The only thing we're really looking for is cmessage data offset, right? Yeah, I think we're just looking for like cmessage data. Okay, we need to look at like what the fuck is a cmessage. uh, right. Okay. So it's like a structure which has these things. It's like a what's it called? Variable sized array, right? So this at the end, like you can make this as big as you want or something. Returns number of bytes of an ancillary element. Yeah. So they're casting a byte slice to this struct C message header. These things are kind of like in the first bit, and then the rest is just like, I don't know, man, we'll fucking figure it out. So yeah, I think all we're looking for, if we're looking for, I guess we're trying to make like a const C, like file descriptor C message, right? Is like kind of what we're looking for here. And this thing has like the same layout as an existing C message. So I guess it's more like we're more looking for a function that we can call that will extract the data. Yes. Yeah. And then what's the difference between C message space and C message size? Or C message len, sorry. Returns the number of bytes of an ancillary element past the data length applies. And then C message len returns the value to store in the C message len. Oh, I see it, which are different. Okay, so we need all three of these. We need C message space, we need C message len. And then the only other thing we need is the data offset of this thing. So that's just these three things. And then we can just write these down, right? It's just literally like const fd's like cmess like fd cmessage space is equal to this. Yeah, I think it's literally just this. Right? Because memcopy, this is going to return a pointer though. So we want like we want this to be minus C message, right? And then we can just fucking take the pointer to the C message start and read the file descriptor out of it. That sounds kind of right. I don't remember how to do multi-line printing in this language, but sure. Oh. So I think it's literally just like this. I guess it's not like this. Yeah, okay, wait, they do need that. Oh, it's like this, I see. Have unsigned car. Oh, sure. So can we do like, what is it? There's like pointer diff t, is equal to C message. And then we could do like, C message data is C message data at C message, and then can we go like this? Yeah, that seems right. C message data minus C message base. No pointer diff? Hello? Oh. Okay. Pointer diff Makes integer from pointer with a cast. How the fuck am I supposed to? Dude, how annoying. How annoying. Can we do like car star this? Mine like like this? There we go, surely. Oh my god, unsigned, fine. Did you mean C message base? I probably did, yeah. Okay. Okay, and then how do I like fucking... Dude, how the fuck do you use this language? Do I really have to do this? Alright. There we go. There we go. After all that, we have our offsets. So we should be able to now just like kind of like take this thing, slap this over here somewhere, and in build, can we, if you put no multiple string littles next to each other, they get concatenated. Oh, right. That is what you're supposed to do. That's way nicer. So can we do like make C message, make FDC message, I guess. And here we're like self B add, we need to like compile the C thing, right? So you need to like add, like compile, like make, create, add executable. And is it like, do we need to do something special to make the root of this thing a C file? I'm not really sure. I guess we'll find out. Root source file is self b path build gen this, right? Target is self b graph host, and optimize is self optimize, right? So here we have like our exe, and can we be like self b add run artifact takes exe, right? Gen like run, I guess, and capture standard output. We want to like return this, right? I guess we need to. This is like our zig source is this, right? And then we like return a module that is root source file zig source, right? Yeah, that seems right. And then we can go like C message, FD C message is builder make FDC message, nice. And then we attach that to our server bind, like our server shit, right? I think. Something like this. FDC message, boom. Let's see if that like compiles. Missing name. All right. Okay. Right, so he thinks that this is like a Zig executable. Can I compile like a C source, like a C file program with this fucking shit? I don't remember. I don't remember. C++, like, is there something that runs like zig cc? Um, like add object, add C something, add compile C++ from build zig. I'm typing C++ because it's like easier for Google to figure out what the fuck I mean. Build zig cc. Like, here we go. This is what I'm looking for. Is there really not a way? That's not really what I'm looking for. Not really what I'm looking for. Yeah, huh. I wonder if it's like not really supported. Which is kind of odd. Like, I feel like I'm missing something obvious, but this is unlikely to give me what I want. But can I do the equivalent of zig cc in a build zig to compile an intermediate helper script or something? Do you think? Do you think he's a fucking lying piece of shit? I mean, neither of these, and none of this is helpful, right? Like, this is obviously wrong, right? Obviously wrong. So whatever. I mean, we can just call GCC, I guess. But like using zig CC makes way more sense. Maybe we can just do that. Right? That's kind of funny. Uh um compile command is this add arg of b self add uh is it appends an input file to the command line arguments. The chop process will see a file path. This might be outdated. Let's see. Because I know that you can like add C source files to a thing, but like it's not really what I'm trying to do, right? Yeah, it's just like this. Oh, maybe it is. Wait, hold on. Oh, the link libc is a trick that I missed. Okay. You know what? That's not crazy. Yeah, I didn't think to try that. Except that these things need to come from root module now, but this is the same shit, right? So we're saying like exe root module add C source files. Yeah. Yeah, good eye. Thank you. How did you find that? Because I was really struggling. Let's just build this exe link libc. Zig build system compile C file. Alright, I guess I'm a fucking idiot. Oh, I guess I'm a stupid fucking idiot. Okay, wait, that does kind of work, huh? So here, can I do like C message? What is it? FTC message is import FTC message. Nice, we fucking got there. Nice. They have DuckDuckGo Premium. Okay, so now we should be able to be like FTC message. What was it? FTC message space. Right? We're trying to make a control of one of this many U8. Right? And control len is this thing, right? So this is wait, hold on. I think it's just this. So this is like control and control len. And then how do we know if this thing has ancillary data? We didn't get that far. Receive message. Ancillary. Ancillary? And man send message. Oh, maybe it's man Unix. Hello. Ancillary right here. Ancillary. Okay. For circle purposes, the ancillary message types below are with a sol socket, even though they're AF Unix specific, and we set the C message level to C message, and the type is from. Okay, so how do I like iterate C message data? Like, how do I know? First header returns null if there isn't enough space for a C message header in the buffer. So I think this is all we care about, right? Is just getting the first header out. So this is C message first header. Ooh, but this returns null if there's not enough space in the buffer. Oh, so this comes from a message header. Wait, okay, hold on. Oh, that's tricky then, actually, right? So this is like... I mean, we just assumed that the fucking message header is at the fucking start, right? I think that's right. So how do we know if data was read into there? That's not clear, right? I guess it will tell us when it reads back, right? Control len probably gets changed, I would assume. So if message header control len, let's just double check the receive message thing. Okay, and the buffers for incoming message. The length and format of the address depend on the address family of the socket. Message flags member is blah, blah, blah. Meaning flag is an output. Okay. So return the total length of the message is returned. For message-based sockets, such as socket diagram, blah, blah, the entire message shall be read in a single operation if the message is too long to fit, blah, 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 blah. In the message header structure, does this like tell us how much things have changed? So like the IOV and IOV-len fields are used to specify where the received data should be stored. IOV points to an array of IOVX structures. The IOV-len shall be set to the dimension of this array. In each IOVX structure, the IOV base field specifies a storage area, and IOV-len gives its size in bytes. Each storage area indicated by message IOV is filled with shoot data until, oh, so then I guess you know how much was returned, how much was filled based off the return value. So what about control? Like, how do we know? It must be that, like, maybe that C message first header thing is doing something like crazy. You know what I mean? Can I don't have Clang. Hold on. Hold on. It's something like that, I bet. Let's look at the fucking implementation of C message first header. Gen this. Or, okay, C message first header. So he's saying if message control, oh wait, yeah, that's great. Right? So, yeah, it's literally just, this gets set. It has to be, right? It has to be that gets set on the output, right? I mean, we can check, right? So we're like, hey, we have this much space for it. Can we just say std debug print here, control len? I think that this must just come out with it, right? It has to. What do you mean? What do you mean? It's fucking there. It's right here. FDC message, right? How come it can jump to definition from... Does capture stood out need to say that, like, is a zig file or something? I don't understand what the problem is. I can see it right here. FDC message is there, no? It's part of exe root module. And it works on jump to definition. Why is everything so hard, man? Make WM. Oh, wait. Where did I put that then? Wait, I'm an idiot. No, wait, am I high? I must have just fucking, I must have been in like an unsaved buffer there. So we pass FDC message to make WM. This goes here. Am I like... I don't know what I'm missing. Okay, comment this up for a second. Just for a bit. Message header, control N. Okay, so why the fuck? Okay, so that's fine until I try to use FDC message dot FDC message space. I think that it's literally something to do with the fact that like why isn't this highlighting? I wonder if zig files have to be zig files or some shit. I'm curious. Can we fprintf? Can we do like file star f is equal to I guess yeah, maybe you're right that I'm like returning the wrong thing. Hold on. Build, make FDC message, right? So here, no, we do create a fucking module out of this thing, no? Zig source is capture std out, which is a lazy path. Yeah, I don't see how this could be wrong. Okay, let's see. Let's take a look in here. Is he doing something silly with the create options? Root source file here. I mean, so he just reads this thing. Which must get used by someone else. Command line takes like an mdat, like this thing. Could be. Just leave root module not after add C source file, I think. But like this, am I crazy? Like I don't think that I'm doing anything C source related at this point, right? I've created a zig file, I've created a zig file in standard output. That zig file like exists and is valid. But I wouldn't be surprised if like it needs to end with .zig or something for it to be okay with this. You know what I mean? You know? I'm curious to know what happens if I change this, if I basically just do this. So this is output comes from who? Stood, build, step, run output. Or can I do this actually? Can I get like, can we get crazy? Zig source generated file. Who did he modify in here? Base name. It was output base name. Oh, so we can't, no, it's kind of hard to do it that way. Okay. I'm curious. Stood, build, step, run, output. We create this thing. We change this to stood out zig or something, right? Just to give it a name. And this is, wait, how did he do this? Fuck. Generated. And it was like generated equals file. Like this, right? This is what he did. Okay. So the question is if I throw stoodout.zig on there, do we behave differently? And yeah, we just start behaving differently. Yeah, that's crazy. That's crazy. So I think that like the command line that the builder is like passing, he needs this thing to be a .zig file for the parser to work properly, probably, right? Because we saw that it was like -m equals something .zig, right? And Zig is probably like freaking out about that. Okay, that's crazy. Yeah, that's fucked. Okay, so I guess what we actually do instead of this though, instead of doing what we just did here, which is hack, we'll just make it so that gen zig z message takes in like int arg c car arg v. Here we say you know, file star out is argv1 fopen this writable mode, right? and then we just use fprintf here. Right? Just leave exe root module null and add exe add c source. But my problem isn't compiling the C source. I know that you said that already, but my problem is not compiling the C source. It is importing the Zig module that was the output of the C source. Right? So that is what I'm doing here, right? But like this part was the problem. You know what I mean? It's like the part was not I have like this compiling C is fine. It's the using the output of the run is the problem. Add output file arg, is that what I want here? Provides a file path as a command line argument, the command line being run returns the latest path. Yeah, so this is now Zig source like this. And now that this thing is like knows that he wants to be fd cmessage.zig. Now we're chilling. Okay, that's crazy. But it's okay. It's okay. It's okay. Okay, so that's just a good thing to have in our head forever, is that Zig source files need to end in .zig. If they don't, then shit will fall over. Unless we've misdiagnosed in some way. Okay, so all of that is so that we can do this. So we're hoping to see now that when we run this guy, we're hoping to see a lot of zeros on here. Control N 0, Control N 0, Control N 0, and then eventually we see Control N 24 because the fucking file descriptor came over. Holy shit. Oh shit, I forgot I'm watching in the past like 20 minutes behind. Ignore me. Oh. No problem. That's funny. Fuck, that's funny. Okay. So, what now? What now? So now if this thing is there, we can check. So if control message header control len is equal to this, right? It's 24. Yeah. Then I think we assume that this is the Linux cmessage, like, oh, do we not even have cmessage header at all in here? Okay. So we might have to do this as well. Cmessage header extern struct. That kind of starts like this. Okay. Cmessage level. Okay. Sure. So then we like reinterpret this thing as that, right? So we look at I guess this is like greater than or equal to size of cmessage header. Okay. We'll use this window manager to KDE. Maybe, hopefully. Now we can just like cast the control stuff to that. So we have our control. There's like std mem bytes to value like this. So this is the header. And then we just check like header message type, was it? Socket, level was socket, and type was writes. Is equal to like this. Then we can probably be relatively sure that this is a file descriptor. So we're going to look at the control plus this guy data offset. Yeah. Right, kind of like this. Yeah. Stood mem bytes as value. Right, like this. And then we push this into the FD list. I think something like this makes sense, right? Right? Sure. Sure. And so now we have to like actually have this file FD list. Oh, what's up here? Fine. Fine, we'll put the brackets in the right spot. Jerk. Okay. Bytes 2 value, I want to copy out. Okay, this is push no clobber. And then I guess this can be tried. I guess catch, we'll just log an error for now. Dropped file descriptor for now. That shouldn't happen, but whatever. Okay, now when we make this thing, we have like an FD list is equal to, you know, I think it's, what is this like? I think we manually construct this thing. Items is equal to GPA, alloc, C int, maybe like 100 of them for now. Surely we'll never be 100 behind. Surely. And then when we say this, we need this requires FD, and this comes from pop now. Right? Something like this. Where is stream reader? It's here. Stream reader. Right, something like this. So now we just need a requires FD thing, which comes from our Wayland binding. So, I guess at the top level of our fucking parsed type, we need to basically write a function on here. I actually want to do this somewhere else. It'll be easier to do it this way. So requires FD, we're going to have requires FD rec the other way around so that we can write this here. And this is going to take in a request as a bindings incoming message, right? And we're going to basically loop over all these guys. And it's like inline, like else, inline else. We have some tag, and like we just check if that guy is something. I don't know. Field rec t or something. You know, sub message, like, or like actual message or something is this thing. So now we're gonna have like a incoming message here. And here, we're going to be one of these. So we have to like iterate into that union as well. So this is like interface message like this. And then we have to again switch on the interface message and do an inline else here. Right? And it's like T2. And so this is the actual message. Like this. And then we return concrete message requires FD. I think it's like something like this. And then in WLGen, all we have to do is put in our thing that it requires message. But I guess this is actually like type of. Like this, because it's going to be like a constant field in that type or something. So now there's going to be like unable to resolve comp time value. Wait, why not? It's like this. How does this work? Zig, lang, ref. Inline else. Num tag. So like this. Okay, expected this. Found oh, so I need to use tag name here. And now it's mad that, incoming message sync has no member requires FD. So now in WGen, all we have to do is on every single incoming message, we just have to write on it if it requires FD or not, right? Which I think is not that hard. Not that hard. So I think it's just like here, probably. Right requires FD. And that's literally just going to be like right requires FD on this thing. And I assume that this guy is going to look over all arg types. Yeah. So it's going to be like, for like var requires FD equals false, right? And he's going to like go event args for event args. If arg type is equal to FD, then requires FD is equal to true, and we break. Then we're just like, try self-writer print requires FD is equal to requires FD. That seems right. What the fuck? Oh, this is right incoming field. Oh, this goes down here actually. Right incoming type. Kind of goes here. And then he's mad because I fucked this up. I forgot the right const. Okay, and then it needs to be pub. Okay. I think that that is mostly there. I guess we should say here, sometimes these guys are not. Some of these messages are empty structs. So for now, I think that we can just write in here. like this. Oh. If it's a struct, I can't switch on it. Sure. So here we need to check, like, if this is an empty struct type shit. You know, if, type of interface message is, like, I guess it's like type info. And it's like, is equal to struct. We just return false. Otherwise, it's a union, and it probably does. Cool. So, like, maybe... Can we say, like, this guy requires FD? Let's just kind of see if this is kind of working the way I expect. Requires. Yeah, nice! So we have this one guy is like, I require a fucking FD. But he's like, it's not in the fucking FD list. Which is shocking. So that means that this guy fucked up somehow? Can we look at this guy? Yeah, it's off by one, right? It's off by one. Interesting. Interesting. Why? Okay, we need to look at that, like, first. We need to look at that first C message shit. He says, give me this thing as a pointer to message control. Wait, is that not what we did? And this is C message length, C message level, C message type. I mean, it's clearly not working right, but I don't, like, it feels like it should. C message length, C message level, C message type. Size, T. Is this, like, behind some sort of, like, define? I don't think so. But I mean, it's clearly wrong, right? If we do a +4 here. Fuck. Oh, wait, hold on. Pointer here. That's not bad. Yeah, I should be using, and control like this. There we go. Wait, that's a little better. Yeah, so it looks like we did manage to get hold of that file descriptor okay now. Theoretically. Theoretically. Cool. So I guess we just have to fucking import that somehow. Can we at the very... I would like to prove to myself that file descriptor is like right. There's a lot of work to do still to get it to like be able to import, but I would love to at least maybe log the file descriptor. So we can say like buff with file descriptor this. And can we at least like do something like... So we should see somewhere buff with file descriptor in big letters. 8, right? And then we should see if we look at ls proc PID, or sorry, 711.120 FD. We do see that file descriptor 8 is a DMA buff handle, right? So it seems very likely that this is right. Yeah, so we see 5, 6, 7, 8. 5, 6, 7, 8. And those are the 4 that are here. So I don't see how it would be wrong. That's pretty sick. That's pretty sick. All right, so that was supposed to be like a 30-minute segment of this 2-hour stream, but instead we spent fucking forever just trying to parse the C message. I am happy with where this ended up because now we can parse this thing with oopsies, with very little overhead, right? We now have the ability to like, we don't have to do like a C API boundary to get this thing, which is nice. We've hooked up to the Zig reader system, so really all we've had to do here is, all we had to do is call read receive message, but understanding like how all of these pieces fit together was like kind of difficult because this new IO reader interface is like a little bit hairy. Not like, I mean, it's like good, but it took me a while to figure it out. But yeah, looking pretty good. So I think all of today was get file descriptor. We did it. So tomorrow will be about trying to get that file descriptor into something that we can display nicely. But all right, cool. Thanks for watching, guys. If you liked what you saw, we stream most days. We aim for 12:30, 4 o'clock Pacific time. It is 4 o'clock now. We're working on this Wayland compositor. If you want to follow along, there's a YouTube link in the description if you're watching live. If you're watching on YouTube, keep watching there. Sometimes we do supplemental content. Today we were doing a bunch of cleanup of our thing. Just like moving stuff around, making better interfaces, that type of thing. So we try to do like non-feature development in like the 12:32 segment. If you want VOD access to that stuff, it goes up on Patreon, YouTube members, or Twitch VODs. We do that so that, you pay in the appropriate place, you get access to that, and acknowledge that you're helping the stream continue, because it will end when I run out of money. So if you want to support, those are the ways. Otherwise, thanks for watching. YouTube, peace out, and Twitch is find someone to raid.